All right, welcome to your first video of conceptual physics. Hopefully there will be many of these video lessons to come. Just to give you the idea of why we're doing these video lessons instead of doing a lesson in class, it's because I found that when I stand in front of the entire class and talk, I'll often take a lot longer than I need to say what I need to say, sometimes taking as much as 40 minutes. And then when I'll sit down and try to explain the same thing to the camera, it makes me a lot more brief. So I usually will only take about 10 to 15 minutes. In fact, I can't even record a video that's longer than 15 minutes. So if it goes longer than that, I have to make a second video or something like that. So because of that, these videos will always be relatively short. I do need to cover a lot in some of the videos, and so I might go rather quickly. Please remember that another advantage of a video is you can always pause it and go back and watch a section again, or stop it and just kind of think about what I'm saying, or stop it and maybe take some notes about what I just said, or think about a question. If you have a question, you can also pull up an email or pull up Neo and send me a message about that right away. There's no stupid questions, and in fact, you don't have to worry about embarrassing yourself in front of the class. You just send me an email and I'll respond and nobody will know. Okay? So a lot of advantages to these video lessons. We're going to do it quite a lot, but we'll do all the practice mostly in class, where you can actually get help and you can talk to your peers about what you learned and go over things in that way. Okay? So I hope this helps. I hope it works. Please give me feedback on the videos by sending me a message on Neo or by telling me in person. If it's not working for you, please let me know and we'll do our best to make it work. Okay, so we're going to be talking about lab reports today. We did our first lab in class, the human measurement lab, and we're going to need to write the lab report for that, like we will do for all lab reports. And so I'm hoping you have your physics lab rubric. Looks like this, and of course it looks like the thing that's on the screen, you know, right there. And so we're going to go through that real quick and try to make sure that you get the best possible score. Notice that it is broken down into 5 different categories that you're going to be assessed on. And for each category, there's a bunch of different scores that you can get. You can get a 6 or a 7 or an 8 or a 9 or a 10 as you go across the rubric. Now obviously we want to be on the 10 side of that. And so in order to make sure that we're on the 10 side, we're going to be looking at just the 10 scores and trying to make sure that our lab report matches that. There's a lot of information on here. And so I want you to know that for the first lab report, we're only going to be focusing on the essential question and background, the procedure, the data table, and a part of analysis, meaning that you actually drew your graph. We'll worry about the rest of the analysis section and the conclusion in class, and mostly we'll focus on that for our next lab because there will be more for you to write in those portions. Okay, but don't worry about doing that tonight. We're just going to do the first half of the lab report. Okay, so let's flip over to my lab report. Your paper should look something like this. At the very least, it should have these sections. And so at the top of the left-hand side of the page, you should have human measurement lab. There should be a part for background, variables, and procedure. On the other side of the paper, it should say data table, and you should have your graph next to that. And under that is space for analysis and a space for conclusion. Please always make sure that you organize your paper exactly like this. I know that it sounds really picky that I would mark you off for not organizing your paper like this, but when I have to grade 140 of these in a single night, if you take me 1 extra minute because of the way that you organized your paper, you cost me 2 hours of time with my son, and that makes me very sad. Okay, so just please do me the favor of making sure you organize it correctly. I will not give you a very good grade if you don't. So simple thing you can do to make sure you get a good grade on your lab report. Also, it helps you make sure that you don't forget anything. Okay, I would take a moment if I were you, and I would pause this video and I would go ahead and read through these sections. So I'm going to go ahead and show you the background real quick. All right, so here's the background. I would go ahead and pause it and read that. Did you do it? I hope you did it, because if not, that's pretty embarrassing. Basically, the idea of the background is you're going to tell us what was your essential question, but before you tell us the essential question, you're going to tell us where did the essential question come from. So usually we'll have an activity or a video or something like that that gave us the essential question or helped us to develop that essential question. You're going to describe that in a short paragraph. So like I said in here, we watched a video about athletes' bodies and how they've changed over time, and that made us think about how our body proportions compare to the rest of the class. And that's our essential question for this lab. Notice that I said in the background section, our essential question is. There's no secrets in here, people. Tell me what your essential question is, okay? Make it very clear. All right. Now, if we flip back to our lab report rubric, you'll see that to get 10 points on the essential question or background section, your essential question has to be well defined. In other words, tell me what your essential question is. And also that you have to include all background information, which means you need to describe what we did to come up with that essential question. Okay? So as long as you did that, you get 10 points. That's probably the easiest section, though I imagine you'll probably be tempted to write very, very, very little on the background, maybe just like a word. You could say something like, we watched a video. That's lame. Say more than that. We need to practice being more descriptive with our language. So try to write in paragraphs all the time, and that usually means saying the same thing more or less multiple times. I mean, look at how I wrote this. I didn't put a lot of time into this, but this is a pretty good example. So it says, in class, we watched a video about how athletes' bodies have changed over time. And then I give an example. So I say the video mentioned how athletes are getting taller for certain sports like swimming. That might feel like saying the same thing twice, but it's actually just giving more detail. And that's how we write good paragraphs. And it's how we get to the point where we can write longer and longer essays and reports and stuff like that. In college, I, at one point in time, had to write a 90-page paper. So you don't do that without repeating yourself a little bit. Maybe you'll have to do that one day too, and we want to practice. So next thing we want to list is the variables, and we'll get into more detail about how to write variables later, but for right now, just list the two things that you measured. I am going to say that I measured arm length and height, but you might have measured different things depending on how you did this experiment, and that's totally okay. All right. Next thing is the procedure. All right, so I want you to pause it again and read through that. I hope you paused it. Otherwise, again, pretty lame. Actually, fun fact, you could almost copy what I did this time. Okay, I just want to make sure that you get a good example. So especially for the background, you could write basically the same thing that I said. And then for the procedure, it's going to be different because I didn't do your experiment with you, and you might have done it a little bit differently than me, but still, it's a good example. And if you're struggling with what to write for each sentence, go back to mine and write something really similar to what I wrote. So just use it as a template. Don't write it word for word the same. I'll obviously notice if that's the case, but please use it as an example. That's the idea. All right, so the procedure in this one talks about what we do, and it gives a lot of detail about how we measured it. Let's go ahead and look at the rubric again. So as far as procedure is concerned, it says to get 10 points, you have to describe the independent and dependent variables. For this lab, you just have to tell me what the two things you measured are. Later on, we're going to learn the difference between an independent and dependent variable, and then you'll have to tell me which one's which. But that won't happen until next lab. You also need to do a diagram of the setup, which I didn't do, but you have to. So right next to the procedure, you're going to draw a picture of what you did. That's to help you very quickly remember what was going on as you flip through the lab reports in your notebook, because there will be a lot of them by the end of the semester. And so this one's just going to be like a picture of you measuring something. Stick figures are totally okay. You don't have to be super artistic about this, but make sure there's a diagram on there for the full 10 points. And then lastly, it says multiple trials are identified. Multiple trials means that you actually measured the same thing more than once. So if your buddy Eduardo is the one that you're measuring, you really should measure Eduardo's height 2 or 3 times. Because you'll be surprised. You might actually get totally different measurements each time. And that's because there's just a little bit of random error every time you measure something, especially when you're trying to measure their height. Like, you can't get this direct line from the meter stick that's over here, over to their height. And so there's a little bit of estimating going on, right? So you're going to get a little bit different numbers because of that. And in all of our further labs, you want to do multiple trials or you will not get full credit. Notice, if you don't include multiple trials in your procedure, you don't get 10 points, you get 6, because that's what the rubric says. So that's bad. Okay. All right, let's move on to the very last thing we're going to talk about. I have 4 more minutes in my video, and so that's going to be enough time to talk about the data table and the graph. Before we flip over, though, look at what the data table has to have. So it has to have column headings that are clearly labeled with the correct units, and it has to have data included for all the trials with averages shown. Now let's look. So, glancing over at my data table, I need to have column headings. So notice it says arm length in centimeters. The thing in parentheses is the unit that I measured with. So in this lab, you probably measured with centimeters, which is fine. I probably would have preferred if you had used meters because, these things are bigger than a meter stick, and that's also just one of the standard units we use in physics. But if you use centimeters, that's okay. Now, if you used inches, inches are bad. And you know why inches are bad? They're bad because when you look at a ruler and you look at the little lines between like 1 inch and 2 inches, they're not decimals. It's not like 1.2 and 1.4 and 1.6 like it is with centimeters. They're fractions. So it's 1 and a 16th, 1 and an 8th, 1 and 3/16. I mean, no one wants to be writing down 1 and 3/16, and you definitely don't want to have to do math with 1 and 3/16 if you're having to like square that or multiply that. It's a lot harder to do those things with a fraction, so just start with decimals, start with centimeters in the first place, okay? We never use inches in this class. The only time you really want to use inches later on in life is if you're a contractor, because still in this country we do measure things like cabinets and the heights of buildings in feet and inches. But pretty much everything else we do in centimeters and meters and kilometers and stuff like that, because they're just better. All right, so as long as you've got that, you're probably going to get a 10 on your data table. It does say that you have to include multiple trials on your data table, so it could say something like this. We could change this. Ooh, that's weird. Sorry about that. We could change this to say 150, and then maybe the next time we measured we got 149, and then maybe the next time we measured we got 150 again. So that would show multiple trials, but we didn't necessarily do multiple trials in this experiment, so we'll leave that until later. I'll remind you of that for your next lab. Okay? Cool. And then the last thing that we want to look at is our graph. The graph has to be labeled in exactly the same way. You have to have what you measured with the unit over here. So it says height in centimeters. It says arm span in centimeters. It doesn't matter which axis you put them on. It doesn't matter. You put height on the top and arm span on the bottom, or vice versa. Either one is okay. Another thing to notice about your graph is something that you probably are not used to doing, but you're going to get really used to doing by the end of physics, and that is drawing something called a line of best fit. Notice, a line of best fit, which I've drawn here, does not touch all the points. It's just a straight line. Imagine like laying a ruler down and drawing a straight line that's as close to all the points as possible. So like when you're drawing a line of best fit, you wouldn't want to draw it like this. That's pretty lousy. That's really far away from all the points. But this is about as close as I could get to all of the points without overlapping any of them. So that's a line of best fit. Make sure you have